Hi, Stuart here. Today we're going to talk about technical debt and related issues. So we have to define technical debt by defining it in terms of its categories. So we have architectural debt, infrastructure debt, design debt, coding debt, and testing debt. There are probably other kinds of debts too, but they may or may not fall into the technical category. So for this video, I'm just going to focus on these 5, but I'm not promising it's 100% of the surface. Architectural debt. It happens 2 ways. The first is there's just stuff you didn't think of because you didn't know of to do. And the second is that you had to do it in a lot less time than was probably wise. For infrastructure debt, it's almost always about bad choices and not anticipating growth. It's also about a failure to control technology proliferation, which we'll touch on some more. Proliferation is a common theme because it's one of the things that feeds design debt. That and a lack of an understanding of what patterns and practices are a good fit to your use cases and a bad fit. Coding debt is exactly what you think it is, right? It's all the things we don't do that we should have done. And testing debt is about usually under-testing or testing poorly. Here's the number one driver of debt. I have yet to work on an enterprise project in some of the biggest companies in the United States, indeed the world, where a POC didn't go to production with the rationale that we'll fix it later. Well, that's generally not a good thing because POCs are usually built fast and they only consider trying out the parts of the system that people are unsure about. They're probably not ready for prime time. The discipline to throw away code and to throw away a POC and take what you learned and sit down and make a new set of use cases which lead to requirements which allow you to define non-functional requirements is really hard to pull off because POCs are sort of a sunk cost, and the sunk cost fallacy kicks in that says, well, we've already sort of done this. Why don't we fix it? And that doesn't work out in my life experience. So everybody's familiar with this curve, right? The cost of bad decisions curve. This is from Gauss and Weinberg. It really isn't about the numbers on the graph. It's about the incredibly steep cost of how much it costs in time, and everything's about money, ultimately. Disproportionately, depending on how late you find a problem. So, I think this is one of the first graphs of these I ever saw. I'm using the oldest one I can on purpose, just because it illustrates the core concept is pay less now or pay more later. And the other thing from a risk perspective, right, is that the longer a problem persists, the riskier it becomes. So technical debt and bad decisions are corrosive in that they not only have a cost component, but they also have a risk component. And sometimes that risk component turns out to be way more important than the cost component. The way that that's usually found out is that something awful happens. You have a set of risks that you may or may not have documented well that become an incident. And the knock-on effects of that incident are completely out of proportion typically to the investment you could have made to, if not prevent it, at least make it less impactful when it happens. In other words, you're buying down the impact part of the risk. So why does tech debt happen? Well, time to market forces are a big deal. As I said, part of that is the duo POC, and then, we actually showed it to some people and they want it Tuesday. We're going to put the POC into production. Requirements change. The only constant is change. Changing of business requirements is generally easier to handle if your code is implemented using a decent architecture than requirements changes that come about because of change in circumstance, usually driven by non-functional requirements. But if you build evolutionary architectures, which is the subject of a different video, you can buy down the impact of that happening. Agile is chaos. I can't tell you the number of projects I've been on over the years that went agile. I like Agile, I like Lean, I like Kanban, I like, but you have to be serious about Agile and have it practiced by people who have successfully brought projects to production. Doesn't make it to production, it's not a success, on time and on budget. Otherwise, what you have is chaos. And in the Agile continuum, right, the important ideas transcend the methodology. It's all about don't make decisions before you have to, and spend your time investing in people and skills and domain knowledge and not on process overhead. Although, if you look at something like some of the high-end Agile frameworks, which I won't name explicitly, they do become process heavy because rather than cherry pick the parts that are best for the project in a particular organization, they just bite down hard on the entire thing. And one of the things about Agile as a principle is that you keep the things that work and are effective, and the things that aren't a good use case you get rid of. When you embrace these big frameworks, for large projects they can be useful, but I'm almost positive you don't need 100% of any of them. They're often built out very completely as a way of making it easier to cherry pick the things that are going to be effective for your project. And that's not a bad thing, except if you forget to cherry pick them and you have people running it who honestly have never, ever been successful. It's hard to be successful. There is no replacement for being successful, and then to be on a successful project and to be a good student of reality. The other thing is that Agile as a process continuum, right, is not a replacement for having a lifecycle management tool like ADO or Jira or GitHub or whatever. You need a place, one place, where all of the requirements and ideally everything else comes into one-stop shopitude so that you can find it. And if you have things like requirements, functional or non-functional or other kinds of constraints or risks, and they're not in your lifecycle management tool, they don't exist. And if they don't exist, you can't act on them. Lack of a culture of craft. Without getting into a rant about outsourcing or downsourcing or parasourcing, I will say this. Where the humans come from and how much they cost is got some requirements import, but it is a distant second to a culture of craft and caring. If you have people working your project who fundamentally don't care, their work's going to be substandard. And unless you have a cycle of craft using an OODA loop, which we'll talk about in a second, then you have no way of knowing if you're delivering with craft, if you're enforcing craft, and whether or not the use of that craft is buying down your debt. And lastly, penny wise, pound foolish. I can't tell you the number of projects that end up overspent because they made penny wise, pound foolish decisions close to the beginning of the project, or the economics got challenging, or the business value perception changed, or whatever, and they became short-change heroes, and so they got rewarded for their cutty behavior in the short term without having to take responsibility for the long-term consequence. And the number one rule there is it's not what it costs, it's what it'll save, to paraphrase famous source. These are the 5 cultural forces that I see that drive technical debt happening and not getting fixed. Lewis Carroll, I think, expressed it pretty well. Promises that budget will fix it later, or we'll get budget to do that, or whatever, never seem to materialize. Good projects have good requirements, and the industry standard for what makes a good any document, a requirement, a design, an architecture, or whatever is the SMART rule. The SMART rule is probably the most concise way I've ever seen this expressed, and I fell in love with it the instant I saw it. And the test of whether something is smart is you show something to the 5 core pieces of any project, and if any of them go, I don't know how to do this, then you have failed the SMART. And you have to call out, as you do that analysis, as people read through the requirements or user stories or whatever you want to call them, doesn't matter. The 8 by 10 glossy photos with a paragraph on the back of each one, whatever it is your jam. If you don't call out missing requirements as project risks, and yes, that means you do have to do active risk management, then you've got a problem. Bad requirements directly drive technical debt because people tend to do things on the fly without thinking them through, and those things have knock-on consequences, or they build the wrong thing, or they build it in the wrong way, and again, those things have consequences. This is one of many models for how to implement effectively a surveillance on your project and how to drive decision making at every level of your project, from the very smallest decision up to the very big ones. And I happen to like the OODA loop because A, it's colorful, B, it's only 4 letters, C, it sounds cool, but most importantly, it describes what I think are the minimal steps required to be applied to everything all the time. And that is, we observe what's going on. We go, how is what we observed relevant to the project I'm trying to deliver? Does it have a now consequence? Does it have a future consequence? Are we doing this as well as we could be doing it within the constraints of budget and time? And then that feeds the decision. Do we decide we're going to, continue to monitor and keep going as we are? Are we going to make a change? If so, what is the change? How are we going to communicate that change? Then we act on that change and we see if we got better or worse by repeating the cycle. Observe, orient, decide, and act. One of the things that makes this OODA loop really resonate with me are 2 takeaway lessons I've learned from almost a lifetime of delivering software. Finding problems without a plan to fix them is futile. And any problem that you find is debt, right? And debt isn't necessarily a good thing. And not being able to detect problems or ignoring problems is even worse. So I have consulted on projects and I said, what is your methodology for doing security testing? Or what is your methodology for doing performance testing? Or what is your methodology to ensure adherence to SHROP standards or whatever? And they go, well, we don't have one, but we really don't have time to make one. And I'm like, if you don't have time to do it right, you'll never have time to do it over. And then I get blank. Bad things happen, and then they send in the cleanup. A lot of people have been credited with variations on this, but I think Deming is probably the thought leader that in industry, as he went over to Japan and he saw the embryonic beginnings of the Toyota quality program and the embryonic beginnings of Six Sigma and other quality things in manufacturing, in supply chain and healthcare and financial services, in whatever, right? He's the one that really took the time to evangelize this. The consequence, though, is Goodhart's very good law that when a measure becomes a target, it ceases to be a good measure. So how do we cross the bridge of those 2 quite contradictory ideas? And the answer is, don't make measures targets. Talk about trends instead and identify the drivers of change. So you don't tell your manager that you have to, some manager that you have to be 80% of this hard target number, because they will manage to that and they will game the system so that their numbers look shiny. Right? This is what happened all over the world when police forces decided to start measuring command success by identifying, how many of these crimes were committed in these zones, and, was it getting better or worse, or they'd set unrealistic targets. And they were not, the cynical among them were not surprised at all when people, in order to hit their metrics so they wouldn't get yelled at, started juking the stats or cheating. So instead, when a metric changes, we got to ask the 5 key questions. What does it mean? Why did it go up or down? Is the change real? Don't forget to ask that one, because sometimes it's a blip. Our reporting period's slightly different or whatever. Does it tell us anything we need to know? So this went up. So what? So this went down. So what? Did we have to change how we measured it? If so, can we really compare the change right now, or do we have to wait? I'm always skeptical of projects with too few, too many, or too obsessive thing about metrics. The thing about managers and people who tend to obsess about things, myself included, is that you can pay so much attention to the trees, you lose your perspective on the health of the forest, which is the thing you're supposed to be managing. My soliloquy on this always includes the phrase, metrics are weather vanes and not the weather, right? Metrics are an approximation, a simulation, if you will, of what's actually going on, the health of the forest. They're not the thing itself. Missing tools and processes are just a huge red flag. And there are some of these that just make me so crazy that when I go into projects, I'm often called out to say, look, can you look over the shoulder of this project team? I have concerns. I'm like, sure, happy to look. Let me get out my checklist. By the way, you can look at my checklist and by taking a look at my PoCs tool, which is up in GitHub and free for anybody to use, just an Excel spreadsheet that you can use to self-rank, but it also gives you a hit list of things you ought to consider doing. I didn't say have to do or must do. I said consider doing, because there is not one size fits all, where all is the project size, project complexity, the culture of the corporate entity you're building in. I speak mostly to corporate folks, but I think it probably applies to government as well. If you don't have a software lifecycle management tool, like any software lifecycle management tool, I worry. If you're all in one place and have an enormous whiteboard, and you can stick 3x5 cards up, in the traditional agile sort of way, great. But the reality is any decent sized project is going to be distributed, and people can't wander into the planning room and move cards around or write new cards right? So you need something electronic. I love any tool that kind of does that. And it's not the tool, it's the discipline around using the tool. They're all perfectly, most of these tools are perfectly good tools. Even something like Bugzilla, which isn't a full lifecycle management tool, is better than no tool. If you've got, and I'll point out that some of these things are free or very cheap. So there's really no excuse for not having it. And again, the lemma is, if it's not in this tool, it probably doesn't exist. It won't get tracked. You can't hold people accountable for it. You can't do planning around it. You can't say, well, we're going to move this back in the schedule and pull this other thing forward in the schedule as a trade because we've identified a dependency or we want to tackle a piece of risk sooner, right? You can't do any of that unless you have a software lifecycle management tool of some kind. Man, I see a lot of just terrible things. We'll talk about patterns and of which 12-factor is a superset of patterns. But you see teams without CI and CD, they'll say, well, we'll build it later. And I said, no, those things should exist before you start coding. And then, disciplines like pull requests, where the people who are signing off on it are actually responsible for it. Joe sends me a pull request. If I just click approve, I didn't do my job. But I should be accountable when Joe's thing is bad. Now, Joe will take a portion of accountability, but ultimately, as the approver, I'm more responsible than Joe was, especially if Joe is junior to me, and my job was to mentor them and be their guardrails, right? If I'm a team lead or an architect or whatever, one of the things I usually end up doing on projects, it's my job to make sure that things are happening. I've seen projects that have no source control. They just have like shared drive somewhere where the code is, but there's no source control. There's no excuse for no source control because Git is free. And centralized Git engines like GitHub and GitLab and ADO and whatever are available, and they're very cheap. But source control is the only way to keep your sanity. The right source control, looking at all the source controls in the universe, 99% of the time these days is Git. If you don't know what source control to pick that one. Because millions and millions and millions and millions and millions of people use Git to successfully deliver software every day. And then if they're missing some key quality checkers, right? Or the quality checkers are in the build pipeline or even after the build, right? We haven't pushed that stuff left. So it gets up in the developer's face. They start coding. One of my favorite things is Visual Studio, but there are other IDEs are available. And good IDEs have something in common, and that is in the margin of your code, and with color and underlines and arrows and circles, and it calls out stuff as you code that's like, this is no bueno. Fix it now. And getting back to the idea of craft, the teams that are told, you don't check this in until all the little yellow triangles go away, until your shop standard compliance checkers and linters and so on all show green, right? Preventing us from inducing debt into the code base. You don't get to check in. And after a while, it just becomes easier to do the flow than it is to resist. DevOps practices, right? I can't tell you, again, how important it is that CI and CD happen way before the first line of code start happening. In other words, the engine's there, we've identified the pipelines, we've identified the essential pipeline components. When someone comes to us and says, we have a new thing we want to build and deploy, you have a bunch of different tooling parts available in your playbook, you scaffold them together, and you make the right kind of CI/CD for the thing and your use case. Configuration. The more sources of truth you have, the more problems you're going to have. I recommend 1. And ideally, but realistically, to get the 1, you'll need 2. And I have a video about that. You can go watch my configuration management. Infrastructure that is handcrafted is an anathema. You want all the infrastructure to be provisioned and configured via automation. I want to be able to create a SQL server or a queue or whatever storage by having a script with parameters and automating its creation and its maintenance. And observability. If you have infrastructure out in the world and you have no idea what's going on in it, then you failed a key thing. And security isn't a one or done thing. It's not a once a release thing. It's not whatever. It's a continuous process, right? Because if you wait till the week before the release and then you find all these heinous security things, the business is going to look you in the eye and go, you're shipping that because you promised us these features on this day. All these things, early and often, beats infrequent and late. And then management. If they can't articulate clearly the goals of the project, it's an epic fail. You are going to have debt introduced into your process because of a lack of clarity. Because you can't help it. Because if you don't know that you're building the right thing in the right way, what you're building is debt. So how do we remediate each of the 5 major debt types? Bad architectures are incredibly hard to fix. And I have seen some splendidly bad architecture, including some things that I thought, how did someone arrive at this? So my advice is that you just avoid having bad architectures by getting as many smart people as you can to look at the proposed technical solution, walk them through it, and have them pepper you with questions and suggestions and what ifs. And business people actually have a valuable part of this process because they know what the business needs to get done. So when they say, well, how would we do blah, 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 and you go, wow, that's a bad sign. It means your architecture has left something out. Right? If you say, well, I think what we do is we'd have data over here and we'd have a microservices and anti-corruption layer. And then, the UI could interact with that. And then, we could have this audit program, blah, blah, blah. Then yay, you've done the good thing. The only way to fix bad architectures is it's really hard to fix them in place. And the further they are from any one of the potential ideal solutions, and there's almost never only one. In fact, I'd worry a lot if an architecture comes along and says, if an architect comes along and says, oh, I have the magic architecture and it works 100% of the time, and don't think about architecture because I got this. Wow, run away. I've done architecture in the real world for real corporate clients with real business needs for a long time. And while I have things that I tend to pull out of my playbook for certain use cases, I don't have a fixed architecture. I do have a general purpose way to think about architecture, which is in my video on architecture. But that doesn't mean that I have like an immutable set of components or approaches or patterns I'm going to use every single time. I want to understand the requirements first, because there may be subtle requirements, especially in the non-functional area, that will conform the decision making. And remember, an architect's job is to look at all the potential solution spaces and decide what will not be. And whatever's left is the architect. Remediation of infrastructure debt. Bad infrastructure decisions, especially when it comes to component selection, are incredibly hard to fix. If you pick database O and you discover for a variety of reasons, like the business comes to you and says, well, it was too expensive, we need you to adopt P. Wow, my migration's going to be risky and expensive and scary. And there's going to be a knock-on effect through all the layers of the application and all parts of the architecture, and it's going to be super hard to do. Other problems like scaling up and down are pretty routine, especially in these days in the cloud, but even in the data center, right? We've sort of commoditized what we've gone to what's called the utility computing model. Things are VMs, right? And we have ways of dealing with scaling up and down and in and out, you know, bigger, smaller VMs, bigger, smaller, whatever, and then the number of instances up and down. The question that needs to get asked is, why are we scaling? Did the code change for the worse? Or is this, are we seeing more load because of business growth, which is good? But don't just, I mean, if you're kind of up against it, you might approve a scaling request, but then you need to put something in your backlog that says, go figure out why this happened. And if it happened for a good reason, yay. If it happened for a bad reason, that's debt, boo. And then I can't tell you how hard it is to fix a badly designed network. In a perfect universe, you have the requirements, you start picking some architectural topologies from the choices. And then as you narrow that down, narrower and narrower and narrower, your networky people, your infrastructure people should come in and start, you know, supplying functional and non-functional requirements or asking questions about, well, this thing goes from here to here. Do we have any concerns about, you know, this being vulnerable or whatever? And this is where InfoSec comes in too. If they're good at their job, they know how to do the modeling, take your architecture, turn it into a security model, like a stride model, and start asking tough questions like, what are you going to do to screw this down? Shouldn't we have a firewall over here? That sort of. And then storage is cheap, but the difference in storage solutions can have serious impact and make debt. So throughput, the cost of ingress and egress, limits on I/O, quality of service, guarantees. Is the storage got HA? Does it have DR? If something goes pear-shaped in your storage, what's your business continuation? Anything where data is going to reside, not just storage. I mean, like databases or NoSQL or whatever. Like if data lives in there, you ought to be asking yourself those questions, because otherwise you've created infrastructure debt. And that debt poses a risk to the life and health of your project. Design debt. The number one thing that makes me mental is fat. People solution before they understand the requirement. And even I'm kind of guilty of this on occasion, because I tend to be able to jump forward because I've done this a long time and sort of go, I can eliminate a whole bunch of different architecture and design patterns in reference to these requirements, because I just know from history that those are a less than good alternative to something else. And so, in the area of microservices, that was a meme. It was fatty. It's not that microservices are a bad idea. They're not bad idea. But in order to make something a microservice, you have to satisfy the prerequisites to make something a microservice? Is it independent and idempotent and all the other things that go with it? And if that's not true, then maybe a monolith is not the worst idea in the world, or a series of microservices over the top of an anti-corruption layer that is the only thing that controls access to the data or operations or whatever. Right? You know, when you're choosing components, the shiny thing, the thing that I like to call resume candy, is almost never a good idea. You know, something that you just know works, like your favorite database engine, your favorite queuing engine, whatever, that your team knows, that your ops people know, that your InfoSec people know, that, and beating back the people who say, look, this particular SQL relational database doesn't do this one thing we want. So we want to add a separate one. And you really need to push back on those things, and you need to say, well, what can we do? And is it even true? I mean, I used to hear lots of arguments against, and I'm just pulling something out of my history, SQL Server, because it didn't do the kind of data structures needed to support geoqueries. That is, queries about maps. How far away is it? How do I route to it? Whatever. But it transpires that a general purpose engine, you can craft those things yourself. And you can add stored procedures that do distance and do traversal and things like that. And so in all but one case, we found a way to do that on vanilla SQL, which means it would have run on any of the big SQL engines perfectly fine. And then over time, those engines got baked in support for that sort of thing, and we quietly refactored without changing the interaction from the front end, and our life got better because now the engine was doing a lot of heavy lifting for it. Don't just choose components because they're shiny. Always choose components and ask, is this a good match for my design, for my requirements, for my team? Am I adding to the proliferation problem? If I am not picking the thing that would be the perfect thing, can I still get a good enough, or am I going to be inducing a debt of a different kind? And here's the thing. When I interview technical folk, whether they're QA or InfoSec or developers or what have you, I almost always poke the bear about whether or not they get that patterns are use case dependent. So first of all, I try to find out if they understand what a pattern is, and then can they name some, and then what would be a good use case for that pattern, what would be a good not use case for that pattern. And if they can't answer that question, it doesn't mean I don't hire them, but it does mean that goes top of the pops of their onboarding training. And if you have a favorite pattern and you decide you're going to use it before understanding the requirements, you're creating technical debt, right? It's previous, as my English friends would say. Remediation of coding debt. This has been talked about ad nauseum all over YouTube. Right? All of the usual things that you do are essential in preventing coding debt, right? And again, little yellow triangles that show up in modern IDEs that say this is not good, those should be 0 by the time you go to do your pull request. Unless they're a false positive, in which case there should be a discussion part of the pull request. Because sometimes, you don't want to. If you turn that into a metric, by the way, what people will do is start disabling those warnings in their projects, and you won't see that they're not right, but they won't be right. And then that has a knock-on effect in production, potentially, and then you're very sad. I've seen programs who refuse to make the metrics various kinds, like how many tests are there? How many are passing? What's the coverage? What's the latest performance test broken down to the XYZ service? Or, what's our total transaction throughput time for, buying a thing or whatever. They want to make them secret. And this is mental illness, because projects run on one and only one commodity, and it's trust. And if you show distrust, I'm not saying a naive lack of monitoring, a naive lack of observability. I'm saying trust but verify. It's the only way which you can deliver. So don't keep metrics a secret. People think that people won't game the metrics if they don't know what they are. I actually was in a meeting about that not that long ago. And I'm like, no, your problem is you're proposing to make the metrics targets instead of understanding the trend in the metric and asking the questions we asked before. And they said, well, that's a lot more vague. And I said, yes, because these things are hard and they have to be done by smart, thoughtful people. And there isn't a number. And if you don't believe me, go ask anybody who's deeply into baseball stats about the pros and perils of sabermetrics. They're not a bad thing. They're not a good thing, just a thing. But they're a thing that has to be balanced with other things. Testing debt. What do we do? There's never enough money or time to test. There just isn't. So do risk-based testing and prefer integration tests over unit tests, because integration tests test whether or not A will talk to B, usually over a wire. Well, that will tell you a lot of things, and you can reuse the integration test for performance, scalability, stability tests. Don't write the same test in more than one place, because every time you duplicate something anywhere, you've either spent more money to do it, or if it's a copy paste, and you change one and the other one won't change, right? And now you have the two watches problem. So pick as few testing engines as possible and make sure that everybody knows how to make them, how to run them, and how to figure out what the results mean. And don't forget that testing is an investment that buys down debt by finding problems as soon as you can. My name is Stuart. Thank you for your kind attention.